Hello, everybody, and welcome to another wonderful day of chemistry. So today we're going to take a step back and take a look at all of our various reaction orders. So if I've got some sort of generic reaction, A goes to B. One of the first things that's important to do is figure out what the rate of reaction is, specifically what the order of reaction is. Once you have the order of reaction, we can then use our integrated rate laws to find the rate constants. However, it turns out that these integrated rate laws are also still one of the best ways to identify the order of reaction. So typically what we can do is, if we don't know what order reaction is, we can try and plot it versus one of our integrated rate laws. And again, one of the things that is worth noting is that by using these rate laws, we have essentially a y equals mx plus b. So we can get all of the essential information out of this graph as we're trying to determine what the order of reaction is. So if you aren't sure what your order of reaction is, try and plot it versus your rate laws. So the easiest one, and usually how you collect the data, is a zero order rate law. However, this is frequently one of the less common reaction orders to see, but it still does happen. So in this case, this reaction is most certainly not a zero order reaction. So let's try and fit it to a first order reaction. So natural log of concentration versus time. In this case, we'll see that it fits a little bit better, but it's still not quite right. So if we try and fit it to a second order reaction, again, now this line looks perfect. So this reaction, whatever it is, I know it's a second order reaction. And the nice part is once you have the correct order, all you need to do is look up the slope, in this case, m, whatever it is, and that's your rate constant. So this gives us a lot of information very quickly. And additionally, it's also a very convenient way, once you know what the order of the reaction is and the rate constant, you can figure out what the half-life of the reaction is. However, do watch out for because the half-life of zero and second order reactions will depend upon what time interval you're looking for, because it does depend on that initial concentration. Also, one of the last things I want you to keep an eye out for is in case of systems with stoichiometry, if I'm looking at the concentration of A, do remember that it's being consumed twice as fast, and so you should adjust the rate constant accordingly. So once you're able to, this means that once you have a reaction, by plotting your rate orders, you should be able to figure out not only which order your reaction is, but what the rate constant is. And from there, you can do a lot of other stuff. Next time, we're going to go ahead and take a step back and try and look at these rates of reaction from a more molecular perspective. Until then, take care.